Alright, looks like we're good. I'm gonna turn this way down. Sorry about that. Okay, we are good to go. Hello everyone and welcome back to another video. Today we're going to be looking at some more WinSock stuff in C, and I was kind of just thinking about this, or the reason why I actually wrote this program was because I was trying to get a link from my phone to my computer, and I could do it through Dropbox or email, but then Google will see that, so I'd rather not do that. So what I figured was, well, I know that I'm able to host a web server locally and I can access it from my phone, and that can send data back and forth using local IP addresses. So why not just build a little simple server that uses an HTTP form that you can access on your browser, on your phone, or whatever device. Other device can even be another computer. But what if we did that and then just had a form in there where you could just send data to the computer? So that's pretty much what we're going to be implementing today, which will be a lot of fun, and it'll be quite interesting. So let me switch over to my desktop and we can go ahead and get started. Alright, so we'll essentially be modifying the code that we wrote in the WinSock tutorials, but we're going to be rewriting it completely. But if you have seen the WinSock tutorials, that is helpful because I'm going to be brushing over that, and we'll be more talking about the actual process of sending data to and from, but I will still be writing the code from scratch. I won't be copying anything. Alright, so we're going to create our main file, and then we'll just do standard IO, and we'll just do printf on hello world just to make sure this works. Oops, hold on, you guys can't see. There we go. Let me turn that. There we go. Wonderful. So it prints out hello world, and then that's the video. I will no. Okay, so first line that we'll need for WinSock is, and I have to mention that this is for Windows. Linux is a bit different, but generally it's the same. It's gonna be the same process if you know how to do a server on Linux. So we're gonna start by getting our Win32 libraries. So if not defined, Win32 lean and mean, then we're going to define it, and this will come into play when we actually start including our Windows headers. So we need to include WinSock first, so WinSock 2.h, then include Windows.h. We also need to include ws2 tcp/ip.h, and you can see on the little pop-up here that these are all files from the Windows kits. Oops. tcp/ip.h, and then we're also going to need include iphl. Oh wow, that is not what. Oh wow. Don't look at the chat. Nobody look at the chat. Don't go to the chat. That's not family friendly at all. All right. You need to include iphl pappy.h. I don't know what that stands for, but this is for IO methods, or the IP address methods. And then we have standard IO, and then we will also need include standard lib.h and string.h. All right. And then to actually get the definitions of the actual WinSock stuff, we need to include our static library, which is going to be done through a pragma. So pragma comment, and this is also Windows specific. So comment lib and then ws2_32.lib. So once again, this is Windows. I'm not entirely sure on how to do it on Linux, but however you get your server library in there, that's how you want to do it. I will, maybe I can, I might look it up and I can post a link for reference. But for Windows, you need these includes, and then we need to include the library. And then when we actually use GCC to compile, we're going to need to have this little switch here, -L for library, and then we need to include the ws232lib, which is what we have right here. All right, then we're going to have a few more macros. These are going to be constants that we will use for our program. So define bufflen 1024. So this will be 1 kilobyte, and this will be how much space we actually allocate to the buffer that we'll be receiving from the server, or from our clients, because this will be the server code. The client code, what's fun about this design is the client code is just the web browser. We don't even need to worry about the client because it is exactly like this. And I'll show you that even we can run our own client and cleverly send messages to it so that it'll format properly, but we'll see. So define bufflen 1024, then we have define address. So this will be the address that we host from, and it's going to be localhost, so 127.0.0.1, and then we need a port number. I'm going to say 5500. You can do anything, just make sure it's not like anything important. But 5500 is a good one. And the only reason I do 5500 is because that's what the live server extension on GitHub use, or on oh my lord, do I have to turn off the chat? If this continues, I'm gonna have to turn off the chat. But yeah, the live server that I use to look at websites that I'm writing uses port 5500, so I'm assuming that it's fine. So, okay, you know what, we are going to pause the, give me 2 seconds, I need to, let me, how do I turn chat off? I am awfully sorry about this. How can I stop? I'm sorry about this. This is bad. Okay, I am sorry, but there's something happening in the chat and I need to figure out how to stop it, but we will continue. So we have our port number and our address set up, and now we need to do our helper methods. It's just going to be cleanup and then reading a file. So we'll look at how this works, but for now we'll just do the definition. So void cleanup, and we'll pass in a socket, which will be our integer representing the client or the server here. So it'll be the listener, and we'll write that later. And then also integer read file. It returns the length, and we pass in a const char star file name and a character double pointer output, so a reference to a string. All right. Now for the actual main method. We're going to have a bunch of variables, and I want to define them up top just so we know where they all are. So there will be an integer res for result, and this will be the result of all of our server operations. So when we start up WSA and other stuff accepting clients, and then we'll also have a send result, which will determine which is the result of the stuff that we send and receive. we'll have a integer running. That's going to be the state of our server, so whether or not we're actually running, and that'll be the driving condition for our loop. Then we will have WSA data, which is a struct, I believe, or yeah, it's just WSA data. And this is going to be just how WSA tells us what we have. So, and we'll just call WSA data, and that will be what we'll pass in a reference to this when we call WSA startup. Then we're going to have our socket objects, listener and client. And what's cool about this is we're not going to be doing multiple clients. We could potentially, but because we're on a browser, what browsers do is they just send you a request and then they're done. They don't keep the connection open because there's no need for it unless there's more requests that are being triggered through JavaScript or some other something else. But for the most part, it sends you the request, gets the response, and then it closes the connection. So we only need to keep track of one client. And then we'll have our struct. So this will be for the addresses. So sock address in, and this will be an address and client address. So we'll store the address for the server, the hosting server, and then the client that's currently connected. And then we have our character receive buffer, and this will be a character array of length bufflen, which we defined up here, 1 kilobyte. And then we have character pointer. This will be a string for the input file contents, and an integer for the length. So input file length. Appreciate the kind words, Tion. Sorry if I axed your name. I think that's how you pronounce it. All right. These will be the variables that we use to store the actual input file contents, which will be this, and we'll see what that looks like when we get closer to that, and then also the input file length, so the length of that. All right. So we'll start with just opening the server and making sure it works. So initialization. So the result is equal to WSA startup. Pass in make word on 2.2, so version 2.2, and then a reference to WSA data, our local variable that we have to store. And then if res, then an error occurred, so I'll return 1. I'm gonna, I'll just print out an error. Print. So startup failed, and you can print out the error code as well. But for now, I'm just going to do a simple print statement, and then yeah, this will be. So yeah, this just prints if the startup fails. Right, and then after this, we have our address already, and then we need to set up the actual socket. So the server socket. So listener is equal to socket, and we're going to initialize it using the family is AF inet. So the inet family, the type is going to be a sock stream, and then the protocol will be IP proto _ TCP. So we're using the TCP protocol. And then if listener is equal to invalid socket, then we have an error with the construction. So printf, and then we will call our cleanup method, and we pass in 0, and then return 1. So cleanup will essentially just allow us to call WSA shutdown whenever we want, and we don't always have to close the listener because it might not exist. As in right now, the socket, if the socket is invalid, we can't really close it. Just playing. I'm sorry. All right. So we set up the server and then we want to bind it. So address.syn family is equal to AFINET. This has to match the socket here. And then we have address.syn address.s address is equal to inet ADDR address. So we're converting the string address, the local host here, that we have into this unsigned long that we will use to store here. Then we will use to bind the server to. And then we set the port, so address.syn port is equal to H2NS. So I believe, I forget exactly what H is, but it's summing to network string, and we pass in the port. I can actually check my notes, because I had this previously. Here it is. Host, it's a, oh, okay. So it's a host byte order to a network string. So we're converting the port, which is the host byte order, to a string. And then now we need to bind. So result is equal to bind, pass in the listener. Then we're going to convert a reference of the address to a struct sock address pointer, referenced address. So this is just converting. So we have this little sock address in here, and this allows us to customize these values here. And then we're just converting it to the more general form. And we pass in size of address. And then if res is equal to socket error, this is an error with the binding. And then now we call cleanup, and we pass in the listener because we have created the listener, so we need to shut it down and then return 1. So this cleanup function will shut down the listener, and we can actually just write that real quick down below. So it's void cleanup, and we have the definition up top, pass in the socket listener, and all it does is if listener and listener does not equal socket or invalid socket, then we close the socket. And then after this, we call WSA cleanup. So notice how we don't call this cleanup function until we have initialized WSA or started WSA up. All right. So we bound the server now, and we need to set it up as a listener. So set as listener. So result is equal to listen, pass in listener, and SO max con. And this is just the maximum number of connections that we can have in the queue. So there's a queue of connections that we want to accept, and they will be sent to this, and that queue will have a max value of SO max con. And then the same little results check here. If it's a socket error, then we just say listen failed, and then pass in listener to clean up as well. All right, next we need to load the file. So printf, or sorry, we will do that once we actually get the server done, or up. So done setting up. So printf, I'm just gonna say accepting on, and I'm gonna print out the address and the port. And then running is equal to 1. So while running, so this will be the loop. So what essentially we're going to do is we're going to have this loop iterate every time we want a client. So we're going to wait for a client, and every iteration of the loop we will get the client. And we're not going to multi-thread here, but we could theoretically do that. But for now, we're just going to have messages only coming in from the clients and not an actual console interface on the server. So while we are running, we need to accept a client. So we'll have an integer client address length. So client is equal to accept on the listener, and we pass a null and null because we're not trying to accept a specific address. We don't know the specific address. We just need to accept anything. And we say if client is equal to invalid socket, then we printf could not accept, and then we clean up the listener and return 1. Then we're going to get the client info. So we have a general client, we need to find the information out. So we call get peer name. We pass in the client, and we're going to cast struct sock address pointer. So this is the same cast that we had above, and we pass in reference to client address. We convert this into the more general form, the pointer of it. And then the length will just be a reference to client address length. So something to store. Okay, I'm sorry, this, I don't know what keeps happening in the chat. I might turn it off next time this happens. All right, so we've gotten the client information, and we can print out that we accepted it. So printf client connected at %s and %d. So a string and an integer. Thank you. Appreciate that. I've been reporting them too. And they're still, I don't know. I will figure it out. So we print out a string and an integer, and the argument we're going to pass in is inet n2a. And we pass an address dot syn address. So this gets the address value, and I'm not sure how. I don't know why this works, but this actually should not work. Sorry, this should then also be address.syn port. So N2A, so this is a network string to a character, or just a regular string. And we pass in the syn address, so that gives us our IP, and then we pass in the port, which is an integer. All right, so we have our client, we printed out the information, and now we need to receive. So res is equal to receive, passing client, receive buffer, and bufflen. So bufflen will be the maximum length that we can accept, and the receive buffer is just the string, the buffer, the character array that we're going to be passing data to. And then 0 is just for no flags. And if res is greater than 0, then we have a message. And then we're going to have two other conditions here. So else if not res, and I'm just going to take care of these because these are just errors. So if there's no res, if res is 0, then that means that the client disconnected. So printf client disconnected, and we're just going to continue. Else the printf receive failed. We print out just that, and then we can also just close the, or then we'll move to the end of this, which will just be shutting down the client. So shut down client and SD both. So we want to shut it down for both sending and receiving, and then we close the socket, and then we say client is equal to invalid socket. hello Rishab. All right. And then after the loop, we're just going to say, we're going to clean up the listener and shut down WSA and then printf shutting down. And we can have a little goodnight message. Just like that. But when we actually do get a message, we will just want to print it out. So we need to actually terminate the string. So what happens is when you get a network communication, it's just bits. It's just signals on a wire or in the air, but it doesn't know if it's a it doesn't know if it's a character or just a number. It's just passing in zeros and ones through electrical signals on a wire. So we need to actually terminate this string because it doesn't actually, or it may not have terminated it for us because the string may not actually, or the client may not have sent a string that has been terminated. So we need to actually just make sure it is. So we say receive buffer at res, so at the end is equal to a 0, and we could check that it's less than 1024, but it's okay. We'll just assume it is, and then we print out the string. So printf \n receive buffer. Okay. So this is just printing out the string here, and I'm going to try and run this on putty. I actually don't know if I have putty. I can check though. Okay. Wonderful. Okay. All right, so we're going to go ahead and run. Hopefully no errors. All right, so we're accepting on 127.0.0.1 at 55 at port 5500. And then in putty, I don't know if you guys can see this, it's very small. But I'm going to connect to this exact address on SSH or just simple. And then we open the connection. Uh-oh. Let me try something. There we go. Wait, no, that's not it. There we go. All right, so client connected at this value, and we're going to type in our message, hello. Can I actually zoom in here? I cannot. So I'm just typing in hello, and we see that it says hello. So what happens in putty is it's expecting the communication to stay open, but because we're expecting an HTTP page or a browser page just to shut down the connection, we're closing the client as soon as we receive a single message. So when it says software caused connection abort, that means the server is just saying, get out of here. No one gives a shit about you anymore. So it's closing down the client because we only want the one client at a time, and we only want one message from the client. And then I can do putty again. But and then we see that this is the port number. That might work. I'm not sure if it actually does. But then we can we have no quit message just yet, but yeah. So client disconnected, and we can see that result is equal to 0 worked. Yeah, WinSock is fun. It's, I think, correct me if I'm wrong, but I think Boost is cross-platform, so it adapts to Windows and Linux, which is good. But WinSock is, yeah, it's specific to Windows. All right, so we have our server working. It is running, and what we're going to try now is let's look at how to use HTML to actually make it so that we can send a message from our phone, because Putty might have an app for the phone, but that's going to be annoying. So why not just we can do this is a bit of an HTTP server, so why not create this or create a little form. So I created this little bit of a form here. I can get rid of this and I can show you guys what the form looks like. So we go live, and so this is what it looks like. You take in a value and type in a message there and hit send. So this file is just what you get from a GET request. And it is not, it's just it has a little bit of styling, and then we have a form here. So the form goes to the page, because we don't want to, it just goes to the top of the page. And we want to do it through a post. So I'll give you guys a quick rundown on how HTTP requests work. So GET is the simplest thing. So I'm passing in whatever URL I'm looking at. So developer.mozilla.org, that's the server. And then I have this little path here, which is this with the /enus blah, 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 blah. And this is a GET request because I'm trying just to get a file from the server. So what ends up going to the server, the Mozilla server, is they have a GET request, and I'll zoom in here. But the syntax is GET and then this little path here. And there's a bunch of other data with it, but this is what you need to get. This is what you need to know. And there's different types of requests. We're going to look at a post request, but a post request essentially allows us to send data with the request. So it's still the post. So it's the method post get, whichever one you want. And we have the destination. So for us, the destination will just be hashtag or just no change. And then the version of HTTP, it has a few other parameters, and then it passes the data here. So this is a query string, and you might have seen this in URLs, but for post, it hides these values in the actual HTTP request. If it was a GET request, if the form had method GET, it would put the actual value as a query string in the hyperlink or in the URL. So we have the data passing at the bottom of the request. So what you need to understand is that, well, what are these names? Field 1 is value 1 and field 2 is value 2. Well, for our form, we only have one input, which is the one text input, and then we have a button to submit. So input type equals submit. This thing right here actually triggers the form to submit. The text input here is the data that we're actually going to be sending. We need to give it a name, which will be this here. So it's a field. It's the name of the field that we want to pass it with. So for us, it's just going to be message. And we'll see that it actually doesn't matter what this name is, because we're just going to be looking for one keyword, searching from the back. But we're giving it a name and an ID because that doesn't really matter. But we have a label. We can do a little bit of customization here, make it pretty. But the gist is there's a label that has just text to tell you what to do. The input is the text input, which has a name, which corresponds to the field name, and then the submit button, which actually triggers the form to send the data to the server or make the HTTP request. Now, when we get this request, we need to respond to it. So you could do something like this. And you could look into this, and there's a lot of things that you can customize. Content length, content type. You can pass in a lot of data in the response. You can actually pass an error code. So a 404 error is not found. And you could give it a little document here that says, all right, I don't have a file for you, so I'm going to give you this little error code here. You can also have a bad request. You can do a lot of things with this, which is cool. But what you can do is you can tell the browser or whatever your client is what actually happened with the request. So for a post request, we're going to, most of the time, we're just going to be keeping an OK request. So that's just the HTTP version 1.1, and then 200 is an OK, is a good value. So that just means everything was good. And then we give it a few parameters, and we won't have many, and then we have the HTML content here. What you'll see is that in this, I kind of just ingrained the response parameters up top. We actually don't even need that, but this is just to help the server, to help the browser. You like jazz? I could play the B movie right now, and Jerry Seinfeld wouldn't be able to do anything about it. Okay, so I need to update this content length because it got formatted differently. But in essence, you need to know that, so 744. Wonderful. So we have our HTML content, and you see it's 744 characters. That might be incorrect, but we will verify that. So we have the HTTP here, version, response code, and then OK. And that's the message that we give with it. Set a content type, text/HTML, because this is an HTML file. And this tells the browser, all right, I'm sending you an HTML page. You can display it as an HTML page and apply the styling. If I said just text/file, it would just display the raw file. And then I give it a character set. And then the content length just tells the browser how long the actual file is. So how much data you need, or how much space you need to allocate to actually store the value, to store the file. All right. So yeah, we're essentially going to be taking in this. We're going to load this file in from memory, from permanent memory into our main memory, into RAM. And store it on the server, and then we will just be able to send it as a buffer, as a string, whenever we want, whenever the client requests it. All right, so for main.c, we're going to start, or we're going to actually get this process started by loading in the file. So before we enter the loop, we need to load in our file before setting up, or after we're done setting up. So load file. So we'll say input file length is equal to read file, and it's just called input HTML. And the output is just a reference to input file contents. So this function we will write. And it just returns a length and sets it in the buffer. And then we're going to say if not input file length or not input file contents. So if something went wrong, then we could not load it. So print could not read input form. And then we're going to clean up the listener and then return 1. So we now have the file in memory, so we can send it. Let's actually write this method right now. So take the definition and we will just write it down below. All right, so we'll start by loading or creating our file pointer. So file pointer fp is equal to fopen. The file name is the file name, and the mode is going to be read. And if not fp, then return 0. And then we're going to get the length, because the user might not know, and we also don't want to just hard code this in, because if we change it, then we have to change that value. But it's easier just to get the length of the file by using cursors. So to get the length, this is just a little trick here. You need to move the cursor to the end. So fseek, the file pointer, the offset is going to be 0 long, and then the origin will just be seek end. So we're telling it to go to the end of the file. And then we get the remaining length. So that's going to be int length is equal to ftell file pointer. So this just gets the position of the cursor. And it's relative to 0, so we don't need to subtract anything. And then we need to return to original position to actually read the value. So fseek, fp is 0 and seek set. And now we need to read. So we have gotten the length, and then we return the cursor. So we dereference output and say it's equal to malloc length plus 1, and then we read the output file, so star output. The element size is length, element count is 1, and then the file stream is fp, and then we do output, dereference of output at length is equal to 0 to terminate the string, and then we close the file, and then we return length. Right, give me 2 seconds, I will be right back. Okay. I just have to shut my bathroom door. I'm not sure if it is making any noise, but it is. Something's up with the toilet. It's not flooding. It's just making a noise, so I'm not sure what's up there. So it's best to ignore it. Okay. So this is our file reading method. We have the pointer, get the cursor length, and read that length. So we read the entire file. So now the contents are stored in input file contents up here. And then what we want to do is, so we're done setting up, and let's actually, so we've read the contents and we can just print it out just to make sure it works for now. And then what we will do is we will actually open up our connection on the browser just to see what the request looks like. All right, wonderful. Let's go ahead and run. Oh, bunch of smiley faces. Would you look at that? Did it not terminate properly? I have no clue. But you see that we have our HTML file here. The content length is 744. And the client connected, which I assume is here. How did it get this? I don't know. Either way, we're going to do a little bit of this. So this is the HTTP request that we got. So I'm just going to, no, stop. There we go. Terminate that. So this is the HTTP request that we got from the browser, and it sent a few because it's impatient. So there's the get, and we have a path. And what we'll do is the path doesn't really matter, but it's just a get request. We have the input HTML and then HTTP 1.1. So the get is our keyword here, and you see there's a bunch of other parameters, and it doesn't make a difference. Nobody, I mean, I don't know. You can configure all your options, but for us, we're just going to be sending an HTML file, nothing specific. We have nothing that we really care about. I think it might have it has the browser that we're using, the agent. I don't know where Mozilla is coming from, but I don't know, don't ask me. But it accepts a bunch of things, but we don't really care because we're saying it's an HTML file. So that's the buffer that we receive. And I can actually delete the print because it got it. And then, so we're essentially going to test the receive buffer against the methods. So we're going to test if it's a get command. So if not mem compare. So we're going to compare the memory, receive buffer, and it's going to be, we're going to compare it to get, and the size is 3, just 3 bytes. And then we'll do the same for post. All right. So if we have a get request, then we want to I'll just print out get, and then we'll send the file. So send res is equal to we're going to send to the client. The buffer will be input file contents, and then the length will be input file length, and then the flags are 0. And if this is an error, so if send res is equal to sockets error, then we'll just print out send failed. So if it's a get request, whatever the parameters are, we just give it the HTML file, the input file. And we don't even need to customize the string here to whatever it is, just because I hard wrote that into the actual HTML file. So it reads the headers with the actual HTML content. All right, and then we're going to test if it's a post command. So else if not memory compare, mem compare will return 0 if the two things are the same. So that's why I'm doing not. So we're going to test the receive buffer against the string post and then the 4 bytes. So we're going to printf post. And then now we actually have to, we're going to send the file back first because it needs something as a response. So we're going to send, we're going to do the exact same thing. All right, and now we have to, so we sent back the file, and let's actually just test this out first. Oops, there we go. So whether or not we post or get, we are going to send back the file just for now. What's up with, why is the client, is it this stupid client? That's the client. All right, so 127. Wow, I don't know what these are. That's just the extra stuff, but we got the HTML contents, which is beautiful. And we see it gets a get. I don't know why it sent it twice, but alas. And we can try typing something in, and if we hit send, we should get a post request. So I'm sending, and we get a post, but either way, we're sending the file back. I need to figure out what this is. So we're good there. Where's the, I'm going to print out the length of the file when we read it. $824. Is that right? 824. Oh, you know why? Because it should be length plus 1. No, I did length plus 1. I don't really care. I don't know what's up there. I'll figure it out. But the point is, it's sending the file, which is wonderful. So get or post, we send the file. And I suppose we can just move this send back. Or, you know, we'll just leave it like this for now. But if we get a post request, that means that there's data. So we need to parse the message. So based on the post request, I'm actually just going to print it out. Just because I would like to show you guys what we are actually receiving with our specific form. So for we're going to run this, accepting there. I'm going to load this up. So we have our get request that we just got, and then we're going to now send in a message. I'll say, this is a test. We send it, and we see it reloads the file, it requests the file and gets it back. So what we get now is this is our post request here. So we still have the same headers. The post is different now. Or the post is the new method. But we have this extra string at the end here that is our query string. And it says message is equal to, and then the contents of the message. So what we're going to do is we're going to read the message or read the received buffer from the back, from the last character, and find this equal sign. We're assuming that the person hasn't tampered with the HTML and inspect element. And it's just that's the last parameter is what we actually want. So we're going to find the last equal sign. So we're going to start. So we're going to say integer I is equal to res minus 1. So we're going to start at the end. So for empty first condition, I is greater than or equal to 0, I minus minus. And if receive buffer at I is equal to an equal sign, then we say I plus plus and break. So we have essentially found the index of the cursor of the equal sign, and we're going to say that the message that we want is after that. So content from cursor onwards contains data. There we go. Okay. All right, so we have the content after the equal sign contains our data. And we're going to print this out. So we received, and it's going to be receive buffer plus I. And let's just test this now. So we're just printing everything. I don't know either, but it's really bad. It's not family friendly at all. I'm trying, but I don't know. This has been the first time that's been this bad. It's happened before, but this has been really bad. All right, so we're gonna print out the content after the equal sign. So we're gonna run. And we shall send a post request. This is still a valid client because it has our HTML value or HTML file. And this is still the post request that will still send a request giving to this IP address. So we send, and we received message. Now this isn't perfect. I mean, we could just, and I could end the video here. But there's a bit more to it. Because what if I want to send something along the lines of /quit? I don't like this. let's see what happens now. We get a %2f plus sign. I didn't type in a plus sign. Essentially, what happens is for HTML is they don't want to send certain characters because that could interfere with numerical values, or could be interpreted otherwise by a parser. The spaces are very deliberate in an HTTP request. So, and new lines. So what it does is the browser will encode certain characters into their hex values based on the ASCII table, and we'll send the letters as they are, and then it'll set the spaces to plus signs. And then what do you use to represent plus signs? Well, you put them as their hex. So essentially, it started with space, and I'm just theorizing here, but it could have just started with spaces where they didn't want to represent spaces or put raw spaces in there. So it puts them as a plus sign, but then what do you use to write a plus sign? Maybe 2 plus signs, but what if you have 2 plus signs? You could play with this forever, but essentially we have the hex values after a % sign. And then the % sign will actually be encoded using its hex value. So what we have to do here is we're going to have to parse this value. So we have our value here. And we're now going to get the length of the message that we actually want. So get length. So integer length is equal to 0. I'm going to say for integer j is equal to I. J is less than res, which is the length of the buffer. J++. So we're starting at the cursor and we're going to the end because that is where the query string is. So we say length plus plus because we always have a character there, and then we're going to do if receive buffer at j is equal to, oops, I'm sorry, is equal to a % sign, the character, then we say j plus equals 2. So what this means is we have a character. We're iterating through the characters. If we have a % sign, then we're going to advance the cursor in the received buffer by 2 characters just to skip over the hex code. Plus signs are 1 character, and they map to 1 character, a space character. So that's still going to increment the length by 1. However, we want to skip over the hex codes because then that would be counted as 3 characters. And then we're going to read our characters now. So read them from the message. So read characters. So character pointer message is equal to malloc length plus 1. And then we're going to do for integer cursor is equal to 0 and j is equal to I, just 2 parallel counters. Cursor is less than length. And then the increment step will be cursor plus plus and j plus plus. So j will iterate through the buffer and the cursor will iterate through the output message. So we're going to get the character. So character C is equal to receive buffer at j. And then we're going to have a few possibilities. So if C is equal to the % sign, then we need to parse, but we will write that later. And then else if C is equal to the plus sign, then it's a space. So we can just say message at cursor is equal to the space character. And then else, it's just the character itself. So message at cursor is equal to C. And then we want to terminate. So after the loop, we say message at length is equal to 0, which is the terminator. And then we print out the parsed message. So parsed print out the length and then the message. And then we're going to determine what the message is. So test message, and we'll just have one command, quote unquote command for now. So if not mem compare, or we can actually just use string compare now. So if string not string compare, string 1 is going to be the message, and then oh wait, no, it wants a const character. Sorry, we do have to use mem compare. So mem compare, passing in the message, and /quit, just the const character pointer, and it's 5 bytes. Then we're just going to print out received quit message. And then we're going to say running is equal to 0, and then we free the message. So what setting running equal to 0 does is, next time, so we go through this, we test our message, all right, running is 0, free the message. Or we have to free the message either way. Sorry, that'll be after the if statement. So we set running to 0, and then we're done here. This is our else if statement, so there's no loops. This is also an if statement, so there's no loops. And then we're done, and then we shut down our client, and then we go back to the loop condition, which is while running. So if running is 0, then it's not going to iterate again, so it will shut down the listener. So yeah. And then the last thing that we have to program is just the hex values. So what it does, so what I'm going to do is I'm going to have a little bit of a loop here. So we're going to say, so we need to get the hex value of the next two characters. So message at cursor is equal to 0. And then we're just going to iterate twice. So for integer k is equal to 1, k is less than 2, less than or equal to 2, k plus plus. And we're going to say c is equal to the receive buffer at j plus k. So we're going at the % plus 1 or plus 2 to get the two characters. And then we say if c, we're going to test the value, test the hex value here. So if c is greater than or equal to the character a, just you can do that because this maps to a numerical value. So if it is, then it's a letter. So it's either A, B, C, D, E, or F. So what we're going to say is we're going to get the actual value from 10 to 16. So C minus equals A minus 10. So we could actually write here C equals C minus A plus 10. So C minus A gets the value after, so gets the distance from A. So if it's A, it's 0, but A in hex maps to 10. So we have to increment the value by 10 if it's a letter. And then otherwise, it's a number, so we're going to say C minus equals the 0 character. And then we say message at cursor, left shift equals by 4, because this is every hex value is 4 bits, so we're going to shift it left by 4 bits, and then we're going to or in the bits, so we're going to add the bits to it. So message at cursor or equals C. We could just do a plus equals, but this is good for now. And then we say J plus equals 2 after the loop, because we don't even need the second counter. We could just say no, we need that J plus equals 2. That's fine. It's good right there. But alas, this is all the parsing that we need. So let's go ahead and run this. So we're accepting on this IP, and I will reload the file just using a get request. So we have our get, and then we'll do a slash blah, 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 blah with a bunch of characters in here, 4217, and then a smiley face, and we'll send it. We got it. Wonderful. So it gets all these hex values, and we'll do some spaces next too, but let's do the other one that we had. So I really don't want to do this. That doesn't have anything to do with what I'm doing right now. But you see that it has a bunch of spaces and the apostrophe. Now let's try doing the quit message. Send. So we got the form back, but it received quit and it parsed commit, or it parsed quit, and then it received the quit message. Shutting down, set the running value to 0 so we did not iterate, and the server is closed. Okay. And we are done. So what I'm thinking for this is maybe we can use some of this code to do a bit of like a chat bot, or maybe not a chat bot, but something along the lines of we could do like a chat between different HTTP pages. But what you could do is also just try doing this on your phone. So you need to get your local IP address. I'm not going to give you mine because I don't know if that can tell you where I am, but I'm not going to risk it. And you could go to your local IP address, the IP address of your computer on your phone, and do port 5500 on your mobile browser. Enter something in the form, hit send, and you should see the value pop up on your computer. I will post a way to get that actual value, but get the IP address. But if you do, you need to set this address to whatever it is. So yeah, that is pretty much all I have for you guys today. I hope you guys enjoyed. Hope you learned something, and I will hopefully be streaming soon. I say that every time, but maybe I will. Where we might be doing some more WinSock stuff, or Data Vault in a little bit. But yeah, I will see you guys soon, and keep yourself safe, and have a good one.